in this part of math, we are going to talk about matrix. And also we're going to talk about what is related, like how can we add matrices, how can we subtract matrices, and how do we know the order of a matrix, and how can we multiply matrices. Okay, and the next video that is a complement for the same topic, we're going to talk about how to find the multiplicative inverse of a matrix, and also we're going to talk about determinants. Okay, for this part now, what is a matrix? A matrix is just an arrangement or an array of numbers or elements. For example, if we have 6 numbers like 3, 2, 5, 1, 3, 1, if I arrange these 6 numbers in this shape and I put around them rectangular brackets, in this case, this one now is called a matrix. This one now is called a matrix. Okay, this matrix now, what does it contain? As you see, a matrix, it contains mainly of rows and columns. Rows and columns. Okay, how many rows here? Rows are the horizontal lines. Here, how many? This is row number 1, which is this one. And also this is row number 2, which is what? Which is this one. So you have 2 rows. Good. And how many columns we have here? We have column number 1, which is this one, right? And you have column number 2, which is this one. And you have column number 3, which is what? Which is this one. So that means this matrix has 2 rows and 3 columns. Good. What is that related, or why do we need to know in each matrix that is very important also, how many rows and how many columns, and that is how a matrix is different from another matrix based on that. So the order of this one now, we have something called what? Order of a matrix. Order of a matrix is number of rows. How many rows here? We said 2. So here row number 1, number 2, that means 2 rows. Times how many columns here? We said, as you see here, we have what? 3 columns, so times 3. So 2 times 3, don't go to multiply them. Just say the answer is 6. No, don't multiply. Just stop like this. It's not multiplication. This is 2 times 3. It is a sign to know the order of this matrix. That means to know, that means the first number here, it represents the rows, and here the second number here, it represents what? The columns. So now I know when you tell me that the order of a matrix is 2 times 3, I know that it has 2 rows and 3 columns, and I know that the first number is the rows number and the second one is the columns number. Good. Now we're going to talk about elements. Elements, if I have an element now, as you see, how many elements inside this matrix? There are 6 elements. 6 elements, that means these ones, 1, 2, 3, 4, 5, 6. Okay, good. If I want to talk about one of them, if I want to talk about one of them, what does it equal, or what is its value? How do I tell you? Do I need to tell you, go to the element that is in the second row and in the third column? Do I need to explain that? No. Just I tell you, go to the element here, A, it means the element, and I write you here just the number. For example, here 2 times 1. What do I mean by that now? For example, here it means find me the element that is here, the number 2, it means rows. That means find me the number that is on the second row. And what does that mean? The first column. Okay, now which element, or what is the number that is now on the second row and first column? This is, as you see, this is the second row. Good. And what is the first column? This is the first column. So that means I'm talking about this element. So that means this is element what? 1. So that means I write it as 1. Okay, another one here, another example. If I tell you element 2, 2, or 2, 3, what do I mean here now? Find me the number that is on the second row and the third column. Where is the second row? As you see, this is the second row. Where is the third column? This is the third column. So that means I'm talking about what? 1 here. So that means, I hope that is clear now, how to find each element on, and how we know the order of a matrix. Okay, if a matrix is like this here, 2, 3, 4, 5, as you see, this matrix, it has 2 rows and 2 columns. If a matrix has same number of rows and same number of columns, in this case we call it a square matrix. A square matrix. And also type of a square matrix, if I have a matrix like this, 1, 0, 0, 0, 0 here, 1, 0, 1, 0. As you see, this one now, this matrix, all of its elements are zeros except the diagonal. Except this diagonal. In this case, we call it what? Unit matrix. Unit matrix. So you understand now these two types just of what? Of matrices. Okay. What we got going on, we understand now a matrix. What is it? What is the numbers? Okay, what's next? What's next now? If I have two matrices, can I add them? Can you subtract them? Can you multiply them? Yes. How? We're going to see how. If I have 3, a number that is outside the matrix, and here is 3, and here's 2, 1, 5. For this matrix now, what does the 3 here mean? It means multiply it now. It means multiplication. 3 is multiplied by the matrix. That means you multiply the 3 by every element inside it. So that means you write equals. Now, 3 times 3 is going to be 9. So you write here 9. Then 3 times 1 is 3. I put it here. Then 3 times 2 is 6. So I put it here. Then 3 times 5 is 15. I put it here. So this is the answer. Okay, what about if this one was minus 3? Same thing, just you're going to multiply by negative. So these ones will be all of them what? Negatives. So you understand now how to multiply a number that is outside the matrix. We should multiply it by every single element inside that matrix. Good. Now, if I tell you now a matrix, and as we know, matrix, it can contain even one single element. No problem. If I have here 3 and here is 5. And I tell you now it equals to an of a matrix that is here 3 and here is x. And I tell you what is x. Good. As long as the two matrices are equal, that means each one equal its corresponding part. So that means or element. That means this one now x equals what? X equals 5. Good. I take another example. If I give you this matrix and I tell you here 3, 2, 2x, and here is what? 8. Then I tell you here it equals 3, 2, and here is 8, and here is 8. And I tell you what is x. What is x? As long as these two matrices are equal, as you see, so that means each one is equal to its corresponding what? Part on the other matrix. So that means 2x, it is equal to 8. So that means 2x equals what? 8. So I divide by 2, so that means x equals what? 4. And I hope that is clear. Good. This is when they are equal. Good. How to add now if I have two matrices? If I have two matrices, this is now matrix 3, 0, 1, 2, 5, 3, plus another matrix here, which is negative 2, 0, 3, and here 1, 8, 0, and 3, 1, 2. Can I add these two matrices or no as addition? Can I add? Okay, let's go now to write first the order of each matrix. What is the order of this matrix now? It has, as you see, 2 rows here, 1 row, 2 rows, get 2 rows, and it has 3 columns, 1, 2, 3. So you write here what? Times 3. And what is the matrix here? What is it? So how many rows here it has? So 3 rows. And how many columns here? As you see, it has 3 columns. So that means in this case, it's going to be what? 3 times 3. So since it is now 3 times 3, is this order now same like this order? Are they the same orders? No, they are not. So in this case now, we cannot add these two matrices. We can add them only if they have the same order. If they have the same order. Okay, if I write them this way, look, if I have these two matrices, now these ones, these two matrices, can I add them now? Yes, as you see now, they have the same order. Both of them, they have 2 rows, and both of them, they have 3 columns. So in this case, I can add them. When I add them now, I'll get a new matrix that also exactly similar to what? To their order. So this order is 2 times 3, and this one is 2 times 3, and also this one will be 2 times 3 as the order, which is rows times columns. Now, I add each element by its corresponding. So here 3 and negative 2, I'll get what? 1. And here is 0 and 0, 0 plus 0, 0. And here is 1 plus 3, I get what? 4. Then 2 plus 1, 3. And 5 plus 8 is 13. And 3 plus 0 is what? Is 3. So this is what? The answer as when I add two matrices. So to add two matrices, make sure that they have the same order. Then when you add them, you add each one by its corresponding. Same thing for subtraction. Same thing for subtraction. So in subtraction, it's the same idea. I need to make sure that both of them has the same order, then I subtract each part. So here we take example here. If I tell you here 3, 2, 1, 5, then I tell you here minus 2, and here's 3, 1, 0, 8. Okay, we have now this example as what? Subtraction. As you have, you see, a matrix minus 2 times a matrix. Okay, this is now, I have two ways here to multiply, to do it. Either the first way is to multiply negative 2 by what is inside, and you change the sign here to be positive. Okay, like here, look. So first way, I leave this one as it is, which is the first one, 3, 2, 1, 5. Then here I change this one to be plus, and I multiply the negative 2, what is inside. Negative 2 times 3 is going to be negative 6. Negative 2 times 1 is negative what? Negative 2. Negative 2 times 0, 0. Negative 2 times 8 is negative what? 16. Now just what? It becomes addition. Now just I solve it as what? As addition. 3 plus negative 6 is going to be negative 3. And 2 plus negative 2 is going to be what? 0. And 1 plus 0, 1. And here 5 plus negative 16, it can be negative 11. This is one way. Okay, is there another way? Okay, can do it another way. Next way, just you multiply the 2 by what is inside, and you leave the negative as it is. So the first one, you leave it as it is here. 3, 2, 1, 5. Then here I keep it minus, and just say multiply the 2 alone by what is inside. 2 times 3 is going to be 6. Then 2 times 1 is 2. Then 2 times 0 is 0. Then 2 times 8 is what? Is 16. Now just say subtract them. How you subtract them? As you see, just say subtract 3 minus 6 is going to be what? Here, negative 3, right? And here 2 minus 2 is going to be 0. 2 times minus 2 is 0. And here now 1 minus 0 is 1. Then here 5 minus 16 is going to be what? Negative 11. So as you see, both of them, they have the same answer. So till now, we understand how to subtract and how to add matrices. Okay, we'll go to the third point, which is how to multiply matrices. If I have two matrices, can I multiply them or not? Okay, if I give you example here, as you see, this is now a matrix 3, 2, 1. Good, this is now a matrix. If I want to multiply it by another matrix, which is 1, 0, 2. Okay, can I multiply these two matrices or not? Can I? As you see, do they have the same order? The order is very important to know before any operation, whether is it addition or subtraction or multiplication. So now what is the order of this one here? As you see, how many rows? It has one row. How many rows? It has one row. Times how many columns? As you see, it has 3 columns, right? So that means times 3. Okay, what is the order of this one here? How many rows? It has 3 rows, right? Good. And how many? So 3 rows, right? These 3 rows. And how many columns it has? It has only what? 1 column, that is this one. So that means here times 1. Okay, do they have now the same order? This one is 1 times 3. This one is 3 times 1. They have the same order? No. Because the order here is very important, because the first number means rows and the second one, it means columns. But those, in this case, they don't have the same order. But can I still multiply them even if they don't have the same number? Yes. But when? We have one condition. In order to multiply matrices, you can multiply them if and only if these two numbers are the same. The two middle numbers of their orders is the same. So that means the first 3 here, what does it represent? It represents number of columns of the first matrix. And what does the 3 here represent? It means it represents number of rows of the second one. So that means when can I multiply matrices? Only if and only if number of columns of the first one equals number of rows of the second one. In this case, I can multiply. Okay, when I multiply, as you know, when I multiply them, I'll get a new matrix. I'll get a new matrix. This new matrix, now when I multiply them, what will be its order? And it's very important to know it before you multiply. Before you multiply, you need to understand what will be the order of the new matrix. Okay, the new matrix, its order will be, keep that in mind, it equals this number times this number. So that means it's going to be 1 times 1. What does it mean 1 times 1? That means it will have only one row, one column. One row, one column, that means it has only one element, one number inside it only. Okay, now, what will be this number now? Look here now, which is the important way here, step here is how now can we multiply? Okay, we understand now we can multiply when, and we understand when. Okay, now let's multiply and get the result of multiplication. Okay, in multiply, you take the row of the left matrix and a column of the right, and you multiply them. But when you multiply them here, pay attention. The first one on the row, you multiply it by the first one in the column. So that means 3 times 1 is 3. Good, thank you, plus. Then you multiply here the second here number. You are going from left to right on the row and from top to bottom on the column. So 2 times 0 is 0, so add 0 here. Then what's next here? 1 here times 2 is 2, so you write here plus 2 here. Now add them, 3 plus 0 plus 2, it's going to be what? 5. So the answer here is 5. Done. This is the result. Is that clear now how you multiply? Okay, we're going to take another example. No problem. So but now you understand when to multiply. Okay, if I have this matrix now, if I have 3, 2, 0, and I have here 1, negative 1, 2. I need to multiply it by this matrix, which is 3, 2, 0, 1, 5, 2, 3, 1, 1. Just I'm taking easier numbers to make the multiplication faster. That's why. But the idea is the same idea, regardless of what the numbers are. Okay, now can I multiply these two matrices or not? Think of it before you continue the video. So think, can I multiply them or not? If yes, try to get the result of the multiplication, then come back here to check. Okay, now what is the order of this one here? Now, how many rows it has? First row, second row. So that means it is 2 rows. So that means it's 2 times. How many columns here it has? 3 columns. So that means it is what here? I write times 3. Okay, this is the order. What is the order of the second one now here? As you see, it has 3 rows. So that means I need to write here what? 3 times. How many columns here? 3. So that means I write times what? Times 3. Now I wrote the order of each one. To check now the order, you can multiply them or not. Go to see the middle numbers. You see, these ones are the middle numbers. Okay, these middle numbers now that are here, are they the same? Yes, they are the same numbers. So that means I can multiply these two matrices. Because now, as you see, this number, it represents what? Number of columns. So number of columns on the first one, as you see, 3 columns, equals number of rows on the second one. So as long as this condition is satisfied, that means we can what? We can multiply. Okay, that means now we can multiply. Good. We agreed that we can multiply. But now when we multiply, we'll get a new matrix. What will be the order of this new matrix? What will be the order of this new matrix? To know what will be the order of the new matrix, we said just you take this number that is outside times this number that is outside. You see? So that means 2 times 3 will be the new matrix. Will be the new matrix. I'm going to write it here. Equals. So that means I'll get now matrix that its order is 2 times 3. What does it mean 2 times 3? That means it will have now 2 rows and 3 columns. That will be the result. Okay, now how can I multiply? Look here, I'm going to use colors for each step of multiplication. Okay, now how can I multiply? Now the process of multiplication. After I understand that I can multiply. Okay, what about on the test? How can you solve these questions easier, by the way? If the numbers are big numbers, it will take time, for example. But look, if you have this question in the test, you have choices, right? When you have choices, by the way, the choices may have different matrices, and these different matrices, they'll have different orders. So if there is only one matrix that it has the order 2 times 3, so go to choose it. No need to do the multiplication. Go to choose 2 times 3. But if you have two of them, like 2 times 3, in this case, you need to multiply. Not need to multiply all of them, but part of them to see the difference. But okay, we're going to see here now how we multiply. Now, as a question, regardless of the test now, this is a question. How can you multiply these two matrices? Okay, I use green. First, we use the first row of the first matrix, and you multiply it by the first row on the second matrix. The first column on the second matrix. Okay, and you're gonna use what? Green. Now, first one here, 3. I'm gonna multiply 3 by what? 3 by 3 equals what? 9 plus. Then you multiply 2 times what? Times 1. 2 times 1 equals what? Equals 2. Plus, I'm gonna multiply now 0 times what? Times 3. 0 times 3 will give me what? 3. So that means it gives me what here now? 5 plus 9 is going to be what? 14. So now since it gives me 14, where I write 14? Look, 14 comes as a result of what? Of multiplying the first row and the first column. So that means you go here, the first row and the first column, you write here what? 14. I'm going to make it also green. Green, just to remember what they are. Good. This one is what? 14. Okay, now I'll use blue. I'll use blue now. What is the second? Now we found now one of them. Okay, what is the second now? The second now you use this blue one also still the same, look, the same first row. You need to multiply it by the 3 columns on the second one. Now you multiply it by this column, you see? And after I finish, I multiply it by this column. So that means each row of the left matrix, it has to be multiplied by each column on the right. So that means the first row on the first will be multiplied by the 3 columns on the right. Good. When I multiply now, I'll use blue here. Look, first number, which is 3, I multiply it by what? By 2. Good. 3 times 2 is going to be 6. Plus 2 times 5 is going to be what? 10. Good. Then 0 times 1 is going to be what? 0. Add them now, it's going to be 16. Okay, where do I write 16? You write 16. 16, it came from what times what? It came from multiplying the first row times the second column. So I go to the first row, second column, and I write here what? 16. Good. I'll use now orange for the third step. Okay, for the orange now, I multiply this one here. You see still the same row by the third column. And in this case, then I finished all the columns. Now, as you see, you multiply the 3 first times 0. It's going to be what? 0. Plus 2 times 2. It's going to be what? 4. Then 0 times 1 is 0. So it's going to be what? 4. Where do I write 4 now? 4, it came as a result of multiplying the first row and the third column. So I go there on the result matrix. I go to the first row, third column, and I write what? 4. And same thing now, we do it for the next row. So you finished now the first row. So this first row has been finished. Now you go to what? To the second row. For the second row. Okay, in the second row, I'll use first yellow here. And I multiply it now by the first what? By the first column. Now, 1 times 3 is 3. Good. And -1 times 1 is -1. Then 2 times 3 is 6, right? I add them now. 3 and minus 1 is 2. 2 plus 6 is what? Is 8. Where I write 8, 8 it came as a multiplication of the second row and the first column. So second row, first column, I go try it here. What? Try it here 8. Good. So what do we need now next? We need to multiply now this second row by the second column. Good. I'm going to use here purple. So when I multiply here this one by this one, as you see, it's going to be 1 times 2. It's going to be 2. Good. And -1 times 5 going to be negative 5. And 2 times 1 is 2. So when I add them now, as you see, it's going to be 1 minus 5 is negative 3. Negative 3 plus 2 is negative 1. So you go try it. Negative 1 here, because it's going to be in the second row, second column. Good. Last time here, I'm going to use y. I multiply this row by the third column here. So 1 now times 0 is 0. And now negative 1 times 2 is negative 2. And 2 times 1 is 2. So when I add them, I get what? 0. So I write 0 here. So as you see in this case now, I got a result that it has exactly 2 rows, as you see, and 3 what? Columns. And it is a result of what? Of multiplying these two matrices. So you understand now how to multiply. I hope you multiplied these two matrices before you watch this one. And if you watch this one now, you can repeat it. You can draw this, the same matrices and multiply it by yourself and make sure it's the same. And you can also make more practice for multiplication if you see you have a problem. Okay, and in this case, you have to be accurate. Sometimes I know when you add, you may add it wrong and you have a number that is wrong, but no problem, because in the you may have a number that is wrong, no problem, because in the test you have choices. Even if you have a mistake of one problem and one number, the other numbers will be the same. So that means you can choose it, either A or B or C or D, you can. But also in the test now, just as a fast way to know how to choose. If they give you now 2 numbers to multiply them, 2 matrices, like these 2 matrices to multiply, they'll give you the choices in the 4 choices. First step, you go to the choices, you see which matrix it has 2 times 3 as order, you choose it. Okay, if I have 2 of them, their multiplication or their order is 2 times 3. In this case, just make one multiplication. Just make one multiplication for the 14 to get the 14. Then look at which of them has 14 as the first number. If you have both of them have 14, just do another multiplication. Then in this case, you're gonna see which one is the right one. You choose it. No need to complete the multiplication for all the steps. So we understand now here how to multiply matrices, and you understand how to add them and how to subtract them. Okay, just extra practice for multiplication here. Look, in indirect way, questions can come. How? If I tell you now matrix A, its order is 2 times 3. Okay, good, thank you. And I tell you now matrix B, its matrix is 3 times 5. Good, thank you. What will be the order of matrix AB? That means when you multiply now A times B, what will be its order? As we said, if this number now equals this number, that means we can multiply it, because here the columns 3 equals the rows here 3, so that means I can multiply. When I multiply them, the result will equal this number times this number. So that means the order of the result will be 2 times 5, so I write the answer. Good. This is now one question. Okay, another question now. If I give you this question, A, the order of matrix A is 2 times 3, and matrix B is equals what? Equal what? For example, here I give you X times Y. X times M. Good. And I give you now the matrix of AB, that means when you multiply them, get what will be the answer in this case? In this case, when you multiply them, the order of these matrices A times B will be here 2 times 8. 2 times 8. Now I tell you what is X and what is M. What is X and what is M? How will we know what is X, what is M? First, since I give you the result of multiplication, that means I can multiply these two matrices. That means the condition that we said, the middle numbers have to be the same, is satisfied. So the 3 and this one, they are the same. So that means X is what? Is 3. Otherwise, I can't multiply them. So that means x is 3 now. Good. Now, how can I find m? Okay, we already said if you can multiply them, the result will be this number times this number. So as long as the result is 2 times 8, 2 came from here, and the 8, it came from the m. So that means m is what? Is 8. So that means now I found what is x is 3 and m is 8. Okay, one more example. One more example. If I give you now a matrix A, its order is 2 times n. Matrix B equals 5 times 10. And now I give you matrix AB equals y times C. Now I ask you now, find me what is N, what is Y, what is C. Can you know what is N, what is Y, what is C? You can pause the video and think of it. How can now we get these numbers? Okay, first step, we said, if we can multiply two matrices, that means if I can multiply this one times this one, that means the middle numbers are the same. So that means the number of columns here equals number of rows here. Since they said this is the result of multiplication, that means I can multiply them. So that means n here is 5. N here is 5. Done. I finished 5. Just how I understand it is 5, because now since we multiply them, the middle numbers here, which represents columns of the first one and rows of the second one, they are the same. So I know that n is 5. Good. Now what is y and what is c? Okay, we said after or when we multiply, after we understand that we can multiply them, the result of multiplication, the order of the result will be the first number here times the last number here. So that means it's going to be 2 times what? 2 times 10. When it is 2 times 10, that means 2 is the y and 10 is the c. And in this case, I understand what is y, what is c, what is 5. So, and it is n. So that means they can ask you about 1 or 2 or 3 numbers. You understand how it works. That is for this video. And the next video, you're going to understand what is the multiplicative inverse of matrices, of a matrix in general, matrices. So we're going to understand what is multiplicative inverse, and also we're going to understand what is determinant. See you there. Goodbye.